want to know about derivative of sine of x, we requires a bit more work than just using those rules. We need to go back to the definition of derivative. The derivative of sine of x as limit as h approaches 0 and like this. And we can also simplify this.
We did not symbolize that formula. We need to expand.
Yep.
Use what to expand?
We need to use trigonometric identity to explain sine of x plus h into
what?
Wait, let me write.
Yes.
Sine of x times multiply cosine of h plus sine of h times cosine of x minus sine of x. Okay, there we go.
Okay.
And divided by h.
Yes. Trigonometric identity.
We can factor out sine of x in the first part. We can factor out cosine of x in the second part.
Yes. Now we want to simplify the formula, right? Mm-hmm. Divide the expression into two parts, right?
Mm-hmm.
Then we can calculate that.
Okay, now we have to calculate the second part, which is sine of h divided by h. As h approaches to 0, sine of h approaches to 0 too. But as usual, you can think sine of h divided by h is limit as that approaches to 0, but no. Consider a circle with radius equal to 1 and the angle h. The arc is also equal to h. And here where I've drawn the blue line is sine of x. So as
sine x.
Sine of x.
Sine of
x.
No, not x.
Sine of h.
Yes.
And as h gets smaller and smaller, the sine of h gets closer and closer to the arc. So sine of h divided by h gets closer to 1. Right? Now, we can, because sine of
use the graph to calculate the limit.
This
right?
is the 1 and this is cosine of x.
Yes.
Cosine of x times 1.
No, you read wrong again. You forgot something. Yes. Now forgot limit.
And now let's calculate cosine of h minus 1 divided by h, right? So we can this. And sine of h squared.
How to get that formula?
We just have to take this square.
On both sides, right?
We take square on both sides.
Yes, you should explain that.
Yeah, and sine of h squared is equal to 1 minus cosine of x squared. and divided by h squared.
No,
Sine of h
You
squared.
should know x and h.
Mhm.
You should.
Oh.
Yes, you should write them correct.
And sine of h squared equal to 1 minus cosine of h squared is also trigonometric identity too.
Trigonometric.
Yeah. And now we know this is equal to 1. We can also expand this into this. Okay. Now it can expand into this. Limit as h approaches to
Take limit on both sides.
yeah, and this is equal to 1 still.
Yeah.
And now we can
Which one we want to calculate?
this one. No, this one we want to calculate. So we move this one to the right side.
Okay.
That's better. And so this is 1 minus cosine OH divided by H equal to 1 plus cosine OH H over 1 plus cosine of H. And this is just equal to 2, 0. So this side is equal to 0. Now this.
No. You should what? It's not equal to 0.
As H approaches.
Yes.
To
you need right limit.
As
You
H
should
approaches
take
0.
limit for both of them.
This is equal to 0.
Hey, take limit is very important. You should write them down. Okay?
Mm-hmm.
If you didn't write them, it's not limit.
Mm-hmm.
Then they are not equal. Okay?
Mm-hmm. This is as H approaches 0. This is just equal to 0, and this we can times minus 1 on both sides. So on the left side, we're left with this. On the right side is still 0. So this must call the derivative of sine of x is equal to sine of x limit as h approaches 0 of sine of x times 1 plus cosine of x times 1, which is this is equal to sine of x derivative, which is equal to cosine of x. We can also use the same.
So it's derivative of sine x, right?
Yeah, it's cosine of x. We can do this. We can use the same method as we use for sine of x to calculate the derivative of cosine of x.
Okay.
We just have to. We will just have get a minus sign instead of a plus sign. Working with functions like sine and cosine is more complex than with polynomials. However, we can express these functions into infinity powers of x, known as Taylor series.
That was the Taylor series, right?
Yeah.
How to calculate sine x Taylor series? You introduce that as you.
Yeah, this is infinity powers of x.
Assume the sine of x.
Yeah, we assume sine of x equals to infinity powers of x. We can plug in 0 for x to find the first term. So the first term is equal to 0.
Why? You should.
We plug in 0 for
Extend
x on the left side, where we have sine of 0, which is equal to 0, and on the right side, we're only left with a because the other terms became 0.
Okay. Yes. Right.
And now we take a derivative for both sides.
Okay. Take out the derivative. Since the original function are equal, so
their derivative must also be equal.
okay.
And now we plug in 0 for x again.
How to calculate this derivative of this in
We
other
use
term?
we use sum,
Yes.
constant sum and power rule to
Yes.
And we plug in 0 for cosine of x and 2 on the left side where we have cosine of 0, which is equal to 1, and on the right side we're only left with b because other term became 0. So b must equal to 1. And now we repeat this process again and again. Duckney gives us all coefficients. And we set x to 0 again. On the left side, we're left with minus sine of x, which is equal to 0, and on the right side, we're only left with 2 times c because the other term became 0. So 2c must be equal to 0. So this is a Taylor series for sine of x. With sine of x is equal to
Is there any pattern of the
yes, the pattern of the sine of x is this.
and is there any pattern of the denominator?
The denominators can be
of those
of the coefficients can be written as factorials of the odd numbers.
Okay.
So this
is a factorial of
the odd numbers.
Yes.
Okay, there. Now we know the sine Taylor series.